welcome to Chemistry at Hannity High School. I'm Brian Brown, and today we'll be wrapping up our notes on naming compounds, our nomenclature chapter. Now, in the last chapter, we looked at names and formulas of ionic compounds. This chapter, we started by looking at elemental substances, whether it was an atom or whether it was a diatomic molecule, an elemental substance. What is the name and formula? Then we got into simple binary molecules, two non-metal molecules. And then yesterday we looked at acids, and they were molecular acids and how we name them. That was probably the most involved of the types of naming we've looked at. But the next step, now that we've looked at these things individually, is to put them all together. And that really adds to the level of difficulty, because when you're looking at all acids, it's easier to think about, okay, just what are acids doing and how do I do acids. But as soon as you mix in molecules and elemental substances and ionic compounds, now you have to first decide, okay, which thing is it? And then you have to remember, without confusing it with the other systems of naming and finding formulas, how do I do that type of substance? So really what we're looking at here is putting it back all together, and how do you tell them apart, and what do you do once you know what it is? So it's just going to be an overview of what we already looked at. So first, you've got to look at the substance, determine whether it's an elemental substance or whether it's a compound. And once you've determined it's elemental, then you break down how you handle that. Once you determine it's a compound, then once again, you break down the compound and look at how you handle those. So it really starts in this chapter with breaking down and understanding, when you first look at a substance's name or at its formula, is it talking about an elemental substance or is it talking about a compound? And that's something that even before chemistry, you probably had a working understanding of this. If it's just one element, it's elemental. If there's more than one element, then it's going to be a compound. So once we determined, okay, this thing is elemental, really the question is, and all you have to decide, is it diatomic or not? Because that's the only thing that can have an effect with names and formulas of an elemental substance, is that some elemental things are diatomic. Now remember, one way to remember this is the German name, Han Fickelbrei. Another way to remember it is the genuine are the diatomics, anything ending in gen or ein, or the hydrogen 7. Hydrogen, go to number 7, which is nitrogen, and make a 7, and you'll see the 7 diatomics. Well, if it's diatomic, so if the answer to this is yes, remember the name really is the same as the name of the element, so that makes no difference. What's important if it is diatomic is its formula is going to be different. You basically put the symbol down for the element, but then there has to be a recognition that there's two of them fused together to make a diatomic, a two-atom molecule. So you've got to put a subscript 2 there. Now, if it's not a diatomic substance, so it's not a diatomic molecule, then it's just a plain atomic elemental substance, and the name is going to be the name of the element, and the formula is going to be the formula of the element, and you're done. That's all there is to it. So when it's elemental, really the only thing you have to decide and remember is it diatomic or not? Now, if it's a compound, we've got more things at work here. So we've got more things to think about, and the systems of naming and finding formulas are more complex as well. So this is really the key to this chapter. Yes, there will be some elemental things you have to distinguish on the test, but there's going to be a lot more compounds. So the first thing we're going to look at is, does it start with hydrogen? So even though it was one of the most complex and the last thing we looked at, it's the first one we're going to rule out here. Is it an acid? If it starts with hydrogen, then we know that the thing is an acid. If it was a name, it'll say acid. So once again, we know it's an acid. Now remember, the keys to acids are remembering that there's a tie, or a connection, I should say, between the anion that comes after the hydrogen in the acid and the name of the acid. Ide anions are hydroic acids, 8 anions were ic acids, and ite anions were us acids. And that's important whether you're going from name to formula or formula to name, is to remember those relationships. And remember, we had the gum reference. If you bite gum, it's delicious. If you ate it, it's icky. Help remember those things. Now, the formula is actually pretty straightforward with an acid. Once we know what the anion is, that's going to tell us how many hydrogens we need, because the total charge has to be neutral. And if it's a -2, that means stick 2 hydrogens at the beginning. So with acids, the biggest thing is remembering the naming idea of ides become hydroic, ates become ic, and ites become us. That's the key to acids. And how do we know it's an acid? Starts with hydrogen. Look at that first. So the first thing you should think about when you look at a formula or a name is it an acid or not? Now, if it's not an acid, then that means we either have a molecule or we have an ionic compound. So how do we tell them apart? Well, does it start with a metal or ammonium? And that'll work. That statement works with everything. So if it starts with a metal or ammonium, that means it's ionic. And therefore, our name and formulas are going to be just like we looked at last chapter. Now, it's maybe been a week since we practiced this, so you need to remember how to do this again. If it's an ionic compound, the name is based upon the name of the cation and the anion. You just look up the names and you say them. Don't worry about how many. Just name the cation, name the anion, you're done. And then for formulas, remember total charge had to be neutral. So a quick, easy way to get to how many cations and anions do I need at a minimum to get neutral is a crisscross reduce method. Now, if it doesn't start with a metal or ammonium, then that means it's got to be our binary molecular compound. The name we're going to name using prefixes. Remember mono, di, tri, and so forth. First one keeps its name. Second one, we change the ending of the name to IDE. And then for formulas, it's just a straight translate, quick and easy. So if it says diphosphorus, that's P2. Pentoxide, that's O5. So just quick translate. Those are really nice to see in the test because you know they're quick and easy as long as you know your prefixes. Now, a couple of things to remember in these different things. First off, back up with the acid. Remember, does it start with hydrogen? But is not water. Don't confuse water with an acid. Water is actually a binary molecular substance. So really its scientific name would be dihydrogen monoxide. So that's one thing to remember. Another thing to remember, molecules are prefix things. Don't get prefix happy, and don't forget to use prefixes with molecules. But molecules use prefixes. So if you're looking at a name and you see prefixes there, dead giveaway that it is probably a molecular substance. Now still ask yourself, does it start with metal or ammonium? And so therefore anything else is going to end up our binary molecular. But if you see prefixes, it's a pretty good solid clue that you're going to have a molecule, a binary molecule. The other thing to remember we only found the names and formulas of simple molecules. So we looked at binary, two element, two non-metal element molecules. So if you see two non-metals, pretty good guess, if you've already ruled out acid, that we've got a binary molecule. And then a reminder with ionic compounds, remember no prefixes. Now that we've learned molecules, everybody gets prefix happy. So when they have Na2SO4, they try and say disodium now. Remember, with ionic compounds, we don't need to tell how many sodiums. The formula is going to be determined by its charge, and ionic compounds are made of ions with set charges. So when you go to do sodium sulfate, you don't say disodium. It's just, I've got two sodiums and I've got a sulfate, but I'm just going to call it sodium and sulfate. You just name the cation, name the anion, you're done. So don't get prefix happy with ionic compounds. That's a really common mistake here. So the big thing is to remember how you do the different things and never apply those rules to the wrong situation. So that is a recap of what we've looked at in the last couple of chapters for finding names and formulas. And that's what you have to know for the test. Good luck.